So my name is Vitaly. I'm a software engineer at Better. So I'm going to be talking about how we used Feast in a ranking system. So I'm going to go with some concept around Feast and ranking in general. And I'm going to talk about lead scoring, which is the ranking system that we've implemented, and kind of where Feast fits into this architecture and kind of some things to consider. All right, so real quick, I think some people know about Feast, but from my point of view, when we were thinking about this, is we have several models, and they are dependent on some feature vector. And these feature vectors, they represent some entity usually. So in our case, in a ranking system, we're ranking leads. In other cases, you might have a relationship where different entities, for example, in a recommender system, have like customers relationship with like items, right? So, but in any case, we have features coming from different places. So in this case, feature view is a term, so is entities in Feast, and feature views are just different groupings of feature sets. And multiple feature views usually comprise of like the feature vector that the model depends on. And there's many different reasons to maybe group these features, but one almost mandatory reason is because they have different sources. So some can come from, I don't know, Excel sheets, some can be S3, Snowflake, and they can have multiple data sources, like in this diagram shown here, Snowflake or Kafka, or both. And if everything kind of works together and syncs correctly, everything syncs into this online store. And then we can use this online store for low latency feature retrieval and in the production system. So that's kind of very high level view of why we needed Feast. So now switching topics a little bit, going to ranking. So ranking models and problems are super vast. There's tons of them. And there is kind of, I'm going to be talking about lead scoring, but there's tons of other ones. But I probably cannot generalize this for all ranking systems, but one important question to ask from an architectural standpoint is, can you score the entity by itself and then later just push that score over to some queue of scores? Or are you thinking of ranking as like, is my list of stuff ranked well, right? So this comes into play of what kind of ranking algorithm you're going to pick. So in our case, we used pointwise. So this made it easy for us to look up something, score it, push it to some other queue of scores, or you would have to think of your whole list of entities as one thing that you're trying to predict on, right? And that's an important question of how you're going to do feature retrieval and how you're going to set up your architecture. So now a little bit about lead scoring. So real quick, a lead is not your customer yet, but you'd love them to be your customer. So you reach out to them and then some way increase conversion or some perceived value. And a little bit about our leads. We ingest leads throughout the day, I don't know, consistently throughout the day. You could say leads may be interacting with your product. You might have more information of them. So there's many different data sources. And another important thing is with time, leads are less likely to convert without some interaction. So in this sense, there's some decay, time decay, and that's more of an assumption that you might have to prove, but that's not a crazy assumption, I think. All right, so where does Feast and a feature store come in? So we have stuff that to maintain this list. So you're potentially interacting with the same entity many times, or the same entity sets many times. And not only are you interacting with them many times because you have to rank, re-rank, and also, but your features are potentially upgrading, updating continuously as well. So that's kind of the complexity there. And yeah, so let's break down that interaction. So in our case, we have new entities. We are updating features for the existing entities because they're interacting with stuff. And we have a decay function. As I said, if there's over time no interaction, then potentially that means a different score. So what this means is every time you predict, you have potentially a different like ranking. So that's important as well. All right, so jumping into our kind of setup, I'll talk a little bit more about, so let me just kind of break down the systems, and then I'll break down kind of the life cycle of the lead coming in and where Feast really helps us. All right, so I think if you take out the right side of this whole diagram, you kind of see like a good platform, data platform. We have stuff coming in, a bunch of data sources, and coming into an offline store, and there's probably reporting systems on top of that as well. So our offline store at the moment consists of S3 sources, and Redshift we use as our data warehouse, and we use dbt to manage data models and also our like training and prediction data sets, which we really like dbt as well. So and then on this side of thing, on the bottom is kind of what Feast helps us glue together. And yeah, it's great. So it helps us materialize things from our offline store to our online store, which we use Redis. And it also lets us keep track of certain business logic as well. For example, in our case, a lead is not a lead after 48 hours. So that makes it easy to, from just maintaining data points perspective, to expire the whole entity and its feature vectors after 48 hours. And that makes it nice in Redis because you don't have too many things to look up or to manage. Kind of cleans itself. And then on the top right is kind of like the lead scoring stuff. So let me break down the kind of different ingestion patterns and features. So the very first thing, right, I said that we have a new lead. It's important to get it scored. So we ingest it right away from a streaming process. We have a lead scoring service that's going to validate the lead, transform it. And at this point, we can score it. So this is where we pass off that score to a queue system, call queue system. But at the same time, we might have to interact with this entity right away, meaning in a minute or so, because it might be part of a re-ranking function as well. So at this point, we ingest this directly into Feast. Direct ingestion is supported for Redis, so this makes it easy. And it's there, so it's living with some features. At the same time, and potentially in the background, we have new features for that lead coming in. And this is, of course, a little bit more time-consuming process, but we can reuse the ETL and all the like data platform infrastructure that we already have that may have already transformed a bunch of features for us and materialize that periodically into our Redis online store. There's two benefits to this and some downsides. One benefit is that you can have some redundancy. So even if we miss some things, it's all good. We can still catch up with our normal ETL processes. We also can reuse a lot of processes to ingest new features into the online store without having to set up too many streaming features and crazy transformations and things like that. And at the same time, right, we have time decay and we have updated features. So the call queue service that knows that we have stuff to call is going to reach out and say, hey, give us the latest and greatest scores and we'll re-rank them. So it all kind of syncs together. And what helped us really glue this whole pipeline is Feast, because it can help us manage these many different data sources, many different feature views, and kind of keep that business logic for leads. So my last slide here. So a couple of things to consider. Again, I think one thing I pointed out, there's probably a different architecture to consider if you're going to go for the learn to rank approach, where you really have to think about the relative ranking of things. In our case, we can score a single thing by itself and then kind of manage those scores in different sequences. Quick, like kind of silly question, but something that might come into play is like, well, in the system, what's the difference between position 5 and 10? In our case, it doesn't really matter too much. In some cases, it might mean that the person's viewing it on the front page or on the second page, right? So that might be really important and might lean towards more of a learn to rank approach. And then, yeah, for Redis is great for lookups, but it's important to understand what we're looking up. In our case, we were looking up an entity by itself or a set of entities for re-ranking, but it never was more than 10,000 things that we're re-ranking at a time because, well, leads expire, so we don't have to maintain those anymore. And then the other thing is, yeah, I guess we just don't have that many leads compared to, or that's the problem set. I can imagine if you're trying to rank 1 million things, that might not come into might not be great, but maybe you could try different approaches where you can filter out using pointwise and kind of like, really think about, do you really need to rank the whole 1 million things that from a client perspective, so, or user perspective. So that's kind of some things to consider. And yeah, and quick shout out to Danny from the Feast and Tecton team that's been kind of holding my hand through this whole understanding of how to integrate Feast into our setup. So thank you. All right, that's all I got. Thank you so much. And let me know if you have any questions.